What's up, OOUXers? Sophia here. I have got a talk that I'm doing tomorrow for UX Sofia, which has nothing to do with Sofia. Well, I'm talking at it. That's all. So it's in Bulgaria, in Sofia, Bulgaria. Very confusing. So I've spoken at this conference many times in the past. I am calling in tomorrow to do a talk for them very early in the morning. So doing a practice run, figured I'd go ahead and record it so I can share it. I will share it after my UX Sofia talk. So some context, the theme for the conference is sustainability. So originally, this is what I was going to talk about. Reducing your users' cognitive load and thus their carbon footprint using object-oriented UX. So, if you didn't know this, the carbon footprint of basically us using the internet is about the same as the airline industry, which blew my freaking mind. This is actually from the BBC. This is also written up in a book that I was reading called Design for Sustainability. It's an O'Reilly book written in 2015. So I looked up the more recent statistic, and yeah, so we don't think about it. We think about it as kind of dematerialized, but apparently there's quite a carbon footprint with using the internet. So this is basically what I was going to talk about first is, bad UX basically means more needless clicking around, which basically means more needless greenhouse gases in the air, right? And OOUX usually equals less needless clicking around because it usually equals a more intuitive design. I would say if you're using OOUX properly, always a more intuitive design. And then you have less needless greenhouse gases in the air. So that was basically going to be my talk. But then I started thinking about it a little bit more and I was like, well, OOUX also sometimes equals more engagement and purposeful exploration. It can actually keep people on your site longer, which is sometimes what you want, especially when it comes to that, the contextual navigation. It's really, really good to help keep people engaged and keep people reading stuff that's relevant to them and helping surface things that are relevant to them, which equals not needless greenhouse gas in the air, but maybe it's a net neutral. So this didn't really feel like the right thing to be talking about. And I'm basically assuming that there's going to be a lot of other people at the conference talking about that statistic and how we can reduce cognitive load to basically get people in and out faster. So again, there's not the needless clicking around. So I pivoted earlier in this week. So I'm actually going to be talking tomorrow and right now to you about how mapping relationships can save the world. Okay. Let's get into it. So a little bit more about me. If you don't know me, hi, welcome to my channel. I'm a UX designer. I'm a UX coach, and I consider myself the chief evangelist for a little something I call object-oriented UX. I wrote this article back in 2015. Maybe you read it. Maybe you didn't. A lot of people read it. The dinosaur article, I call it the dinosaur article because it's got dinosaurs on it and it's also from 2015. So it's pretty old. I've basically been doing OOUX ever since. It has become my career. I've written lots of articles on A List Apart, as well as on my Medium. I talk about this all over the world when I am traveling. I bring this to companies. In these companies you see here, I've trained more recently. Zeke is going to talk to us. More recently, Adobe, Shopify, Autodesk. So bringing this to really big companies, Google, very exciting stuff. I also have a happy hour, which you are welcome to come to. And I have a podcast as well that I host. And of course, I have my online course, which is a 22-hour masterclass. And I also have a certification. So all things OOUX. All right. So let's talk about relationships and how relationships can save the world. So first let's talk about, what am I talking about? Why do relationships actually matter? Okay. So why does it matter to connect the dots? Okay. Let's get into the why first, getting ahead of myself. So, and I'm not talking about relationships in the way that you might be thinking. I'm not talking about interpersonal relationships, even though I am showing a picture of a baby right now. This is my nephew, which I have a very strong relationship with. So what I want you to do is just think for a moment. If you were going to explain sticky notes to a child, maybe not a baby, that doesn't yet really speak English, but like a 2 or 3-year-old or an alien or something, if you were going to explain sticky notes, how would you do that? How would you start to describe a sticky note? Just take a moment and think about it. Pause the video. Okay, so most likely you are using terms like paper or glue or adhesive, or maybe even something abstract like idea, putting ideas on small pieces of paper. So most likely you are using other concepts, right? And this is a very interesting phenomenon to start thinking about. The fact that, as Richard Saul Warman says, you only understand something relative to something you already understand. Try to define anything without using other nouns, without using other concepts to compare and connect. I've actually done this exercise where I've gone through the dictionary and looked for words that don't use other nouns to describe them. It's very, very difficult to find. I don't think I found any nouns that didn't have other nouns in the definition. So we live in this interconnected world. And because we live in an interconnected world, it's really important to understand those connections if we want to drive change. The thing is often the connections are very, very fuzzy. All right. So take something like energy production, for example, probably one of the most important things when it comes to sustainability. And there's all these concepts floating around, like the energy sources, the actual power plants, the products we use, the watts that come out of the power plant, the watts that our products take, the waste products that are created from power plants. Like there's all of these things and all the ways that they connect. And our understanding is really so much foundationally based on our understanding of how these things actually are related to each other. So if we have really good tools for mapping these relationships, we can build understanding so that we can drive change and that we can explain to other people. So much of the problems in the world is because people can't make really informed decisions because they don't understand the connections between things. They don't understand the connections between the products that they buy, maybe the habitats that are being destroyed, or the brands that, are involved in these destructive practices. So taking any kind of issue, whatever it is, the more we can understand the relationships between the things, the more we can move forward in a really intentional way. So Rachel Levinger says in her very famous seminal piece, Content Strategy and the Philosophy of Data, which I believe is also a list apart, boxes and arrows maybe, Google it. She says, there are many factors that determine whether something is meaningful, but the primary one, at least as far as web applications are concerned, is relationships. And Rachel, I'd take it even a step further. I would just say there are many factors that determine whether something is meaningful, and the primary factor is relationships. All right. So a power plant, let's take a power plant. A power plant is really meaningless. If you're trying to drive policy, if you're trying to make a voting decision, if you're trying to make a website that helps inform people about power plants in your area, power plants in your country, without connections to the other important things, the power plant becomes much less meaningful, if not completely meaningless. So a big takeaway here that I want you to take away is mapping relationships can help us build better understanding, and understanding reality and facts is how we drive change. Okay, we can't very well drive change if we don't really understand the stuff that we're trying to change. So, just as a side note, okay, this has nothing to do with really sustainability, but current events. So when everything went down in the United States earlier this year, that was this year, right? Earlier this year, where Roe v. Wade was overturned, that even though I kind of heard that it was coming, it really did blindside me. And I was very confused. I didn't really understand how this could happen and all the factors that came in to something like this happening. So what did I do? I got my toolbox out. I started identifying the things, the objects within this system, and started mapping some of those connections to try to build a better understanding. This helped me so much to be able to have better informed conversations, to be able to ask better questions, and to even be able to understand how I can move forward with this new understanding. So this is something that I use. Not only I use it as a consultant. invented this methodology as a consultant, the one that I'm going to be showing you. I invented this because I needed to get quick understanding of complex domains as a UX consultant, just being dropped in and, people needing wireframes in 3 days. And I didn't even understand something like B2B insurance policy making, right? So I would use this to be able to understand my client's domain very, very quickly. So whether it's for your UX work or just understanding something, even understanding some complex fiction, right? You can make a little system model to try to understand how things are working out. So this is a really good tool that you can really apply to anything. Okay, so the first step of this, if you're trying to map relationships, is figuring out what dots, what are the nodes, right? What are the things that need to be mapping, that you need to map? So how do you ID the important concepts? What actually matters? And then we can figure out all the lines that we're going to draw between those things. So stepping back a little bit, object-oriented UX, I haven't really defined it yet. So let's go ahead and squeeze in a definition of object-oriented UX. This is a philosophy for designing digital systems that respects the fact that people think in objects. Because people think in objects, they need consistent, recognizable objects to understand an environment or product. And if you're not quite with me on the fact that people think in objects, please Google the object-oriented user, or Don't Dead Him is another article that I've written. I've done a whole lot of research into the cognitive science and how people think, how people perceive, and it really does boil down to understanding what objects are, where they are, how they're related, what we can do to them. So that's object-oriented UX, and thus people that practice object-oriented UX deliberately align their software to the user's real-world mental model of concrete and defined objects. So these abstract objects that we're representing in the digital world can be as naturally intuitive as possible. Okay, so that's object-oriented UX for you. So OOUXers answer these questions before designing a single screen. First, what are the objects in the user's mental model, or whatever the problem domain is that we're trying to tackle? What are the objects' relationships to each other? What calls to action do objects offer? And last but not least, what are the attributes that make up the objects? And this aligns to my very favorite acronym in the whole wide world, ORCA. So we today are just going to be really tackling the O and the R, what are the objects and what are their relationships between the objects. Okay, so let's define objects quickly. All right, I can keep throwing that term around. So objects are the archetypical real world concepts that have value to the business and or the user, or just the objects in the problem domain if you're doing something like OOUXing power plants, for example, or energy production. So they make up the user's mental model, the business process model, the domain. They're basically those concepts, right? So I'm not talking UI or components or anything like that. So think people, places, and things when we're thinking about objects. Okay, so quick exercise. Think about energy production. Okay, that's what we're going to be talking about for most of the rest of the talk. What are some objects? If you're thinking about this, just the domain of energy production, what might some things be in this problem domain? Give you a few: power plant, fuel input, power plant design or type, like a blueprint of a power plant, which I think is different than a power plant. What are some other things? Laws, health hazards, accidents, right? Output, or the energy unit that's coming out, waste products, waste storage, energy storage, and there's so many more. Okay, so that's just from the top of my head. You probably came up with other ones, and this is one way to do it, is just to basically see what comes up in your mind, but there's actually a more methodical way to figure out what are the objects in a system, and that's something that I call noun foraging. So noun foraging is the process for looking for potential objects by gathering relevant nouns that people are using repeatedly across multiple sources. All right. So it's going through the material and looking for nouns that get used over and over and over again. Now, if you're doing this for like a website redesign or creating a new app or something, you're going to look at the current system, if there is one, competitor systems, look at all the labels. You're looking at marketing sites, case studies, existing user stories, forums, basically places your users would be hanging out, articles, books, podcasts, that kind of thing, stakeholder interviews, user interviews are the gold right there. Customer service chat logs are great. Search analytics, there's so many different places. You basically want to go as broad as possible. Now, if you're doing this to, let's say, drive policy change, you're just going to be modeling that domain, right? So you're going to be looking potentially at Wikipedia articles, news articles, things that policymakers are saying, and pulling from there. So what might this look like? Let's say that we are trying to build a new website that helps people understand energy production in their area and helps people make decisions, helps policymakers make decisions and voters make decisions about where they're getting their energy from moving into the future. Okay, so this might look something like my noun foraging. I would probably spend a lot more time on it, but this is a little sample of noun foraging. I might look at Wikipedia, so things like power stations, and pull some of the objects. We've got generating station, power plant, generators, renewables, solar, wind, geothermal, energy source. Okay, so I'm going to be circling those. I usually print a lot of stuff out. Got my blue highlighter. And then I'm going to be putting all my potential objects on blue sticky notes. Blue is very important. We love our color coding in OOUX so that we can read each other's maps really easily. So I'm going to put those objects on blue. Looking at here's like another snippet from a news article, or like an explainer article on, I think like a power company website. So I'm seeing power plants, transmission lines, regional entities, distribution lines, system operators, balancing authorities. Here's a bit of an article from Harvard about nuclear power and the pros and cons of nuclear power. So we've got carbon dioxide, the Paris Climate Agreement, baseload energy source, governments, hostile attitudes. Like I'm even bringing stuff like that into some of these more abstract concepts, and pulling out the nouns. Now, you can also go, of course, to who would your audience be? Who would your users be for this site? So you might have a homeowner and voter saying, I want to understand what kind of plant my electricity is coming from and see if I have choices, which I tried to do this. This was actually really difficult for me to do. I couldn't, in like 15 minutes of Googling, I still don't know where the power plant is, where my electricity comes from. I want to explore new power plant design so that I can better recommend ideas for my district. I don't really understand the various accidents and dangerous incidents that might occur with various types of power production. There's a proposal for a nuclear plant nearby, and I want to understand the risks before I vote yes on this proposal. Okay, so this might be a resident and a voter. So I can grab nouns from here too. And now what I can do is now once I have all these sources where I've been looking at all of these nouns, I can basically pull them all together and start doing an affinity map. All right, so I can start arranging these and grouping them and clustering them and looking for synonyms. Now, at this point, I'm going to kind of gloss over some of this. This is a little bit of a tease, but basically I'm doing a little bit of prioritization here. So I might say, like, basically maybe the people that I'm working with on this new website or how I'm deciding to prioritize this. I might say, okay, this whole like organizations and representatives in districts, that's going to be, we're not going to necessarily directly be representing that on the website. It's out of scope for now. The details of the electrical grid, transmission lines, grid operators, out of scope as well. These down here are pretty much all synonyms. So I'm just going to pick my preferred term of incident, because it might be could be a good or bad thing. I want a kind of a neutral term. And then generating station and power station are also synonyms for power plant. I'm going to pick that preferred term, and that preferred terms might change, but you kind of want to like get a good anchor term moving forward with the work. And then also can also be different synonyms for plant design. Now, getting to this section here, we got some interesting stuff happening. So when I focus in here, I'm in here too as well, I've got some other cards here that could be objects, but also are actually more like instances of objects. So what we do in OOUX, we put core content, but also instances on yellow. So basically energy source, we've got some examples of energy source, which would be solar, wind, thermal, oil, coal, nuclear. So I'm going to kind of put those aside as good examples of energy sources. And then in pink, I'm going to have my metadata. So ways that maybe those instances could be grouped. So renewable versus fossil fuel. And then those greenhouse gas emissions and CO2 metric ton emissions. Probably those might actually be synonyms too. I'm actually not sure. Is it the same thing? CO2. Greenhouse gas is probably other stuff other than CO2. But these seem like they're going to be metadata, most likely on the power plant or even the power plant design, right? Like, so average greenhouse gases for a certain design. Okay, so this leaves us with these 4 objects, okay? And of course, this process takes usually days, hours, days, all right? I'm zipping through it. And you might be thinking here, okay, what about this plant design and power plant? Those seem like really, really similar. And they are similar, but I do want to have these 2 separate concepts because the plant design might have many power plants that are based on it, okay? And it just a little bit of foreshadowing. We're going to get into relationships in a second. One of the issues actually with a lot of power plants is this ends up being a one-to-one relationship where there's one design for one power plant, and that design is usually not reused or not actually designed to be reusable, which is actually a big problem with nuclear and the cost of nuclear energy. A lot of those are kind of like these ad hoc designs. So I really wanted to illustrate that and illustrate that maybe even you have conceptual plants. So we might have a plant design that doesn't have any actual power plants that have been created from it. Or we might have a plant design that's been really successful and has a lot of power plants that have been created from it. Okay, so because I know that there's this relationship between these 2 things, I want to separate them out as 2 separate things. Make sense? Okay. So looking at power plant, let's talk about SIP and how we actually decide if something is an object. And this is something that you can run through in the beginning, especially when you're noun foraging and you're pulling all your objects together. Like, you might be thinking, is this an object or is this not an object? What you want to look at is structure, instances, and purpose. So structure comes back to those attributes. So can I start naming some attributes? Does this thing have structure to it? So a power plant probably has a name. It has the date that it was installed. It might have a photo of it. It's got location. It has an energy source. It has connections to other objects. Okay. It's feeling like an object. It's got structure. Instances, can I come up with some examples? So in the same way that we were looking at instances of our energy source, all right, so wind, thermal, uranium, okay, we can have instances of a power plant, and I actually looked up some. These are actual power plants in my area. So yes, power plants can have instances. And then this is a little bit more fuzzy one. We want to look at purpose too. So did we hear it from the horse's mouth? Did we actually hear people saying things that show that this actually it deserves to be represented within our system, right? There's a purpose to having it shown, right? It has, if you will, it has a job to be done, right? So if people are saying, I want to influence the decision of a power plant that is proposed for my area, you're hearing the word power plant come up as people are talking about it in a way that shows that it's going to be very useful to have this as a part of your system. All right. So that's it. That's the things that you want to look for when you're trying to decide on what your objects are. Okay. So your big takeaway here is to connect the dots. You have to get clear on your dots, and you can do this by noun foraging as many sources as possible. All right. So now let's talk about strategies for actually making the connections. So first, let's talk about a relationship. Let's define the relationship. Define a relationship. A relationship is the connection between 2 objects in a given context or a domain. All right, this is important. You could have 2 objects in a different context and the relationship might change. Okay, in OOUX and also in a lot of technical conversations, we need to define cardinality when describing the relationships. And cardinality is a really hard thing to define, so I like to give examples. So energy source has 0 to many power plants that use this energy source, right? While a power plant has 1 energy source that it uses. I believe this is true. All right. So far from my research, a power plant is usually only 1 energy source, that it gets power from. Okay. But that might be a question for my subject matter experts. Is this a has 1 relationship, or is this maybe a has 1 to many relationship? So that's where we get into this cardinality questions. Okay. So to try to define cardinality for you, cardinality is what defines the relationship between 2 things by specifying how many one object might have of another object. Okay. So just like the example I just gave. All right. So moving on, what is a system model? So a system model, once I even have two, I have a small system model. And then once I add a third, my system model starts growing. This is a diagram showing the cardinality of object relationships. It's often called an entity relationship diagram or an ERD. In OOUX, we just call it a system model. A little less stuffy, maybe. It's a model of your system, right? And system models are great. I use them all the time. You saw me using a little bit of a system model to try to map out what was going on with abortion and the overturning of Roe v. Wade. I was using a system model. Okay, it's great to do napkin sketches. The problem with system models is even though they are really wonderful for getting the big picture, once you start adding additional objects, once you have like 6, 7, 8 objects, and some of those objects have multiple different kinds of relationships too, system models can actually get really messy. They turn into a bowl of spaghetti. But we've got a trick up our sleeve. I have a tool for you, and that is the nested object matrix. It is much tidier and much more scalable, but it can be a little bit difficult for it to click for you at first, but once it does, it's going to be such a power tool for you. Okay, so the nested object matrix is an object by object matrix. So you basically, whatever your objects are, you're going to put them across the x-axis and across the y-axis. Same exact objects, okay? And what it does is it lets us methodically explore all the potential relationships between the objects, okay? So now we have all of these intersections to think about every single potential relationship and both sides of the relationship, which is really freaking cool. So what I call these objects across the x-axis the host objects. That'll make a little bit more sense later when you look at the object map. I call them host objects. And then the rows that we have our objects down the y-axis that create these rows, I call these the nested objects. So you can almost think about each of these columns that we're about to create as like a proto detail page. All right. I'm starting to say that if I'm looking at the plant design detail page, I might see other plant designs that informed this plant design. I can see the actual plants that were based on this design. Okay. I can see the energy source of this plant design. All right. And so on. Okay. And so not every intersection is going to have a relationship there, but I at least get the chance to very methodically explore all these relationships. I can see, okay, if I'm on an energy source detail page, let's say I'm on the wind detail page, I can see all the plant designs that use wind. I can see the plants that are actually, maybe even plants near me. So where's the nearest wind farm? Maybe I want to go visit it or something. And I can see maybe related energy sources. So if it's wind, I might see geothermal or something next to it because it's similar to wind, or solar. And then I might see incidences related to this. So, with wind, I think large flocks of birds going through, or noise pollution or something like that. So maybe somebody protesting because of the noise pollution could be an incident, related to a particular energy source. Okay. So this is an awesome tool because even if you have 100 objects, which a lot of my clients do, or in dozens of objects, this is something that actually scales, and you can go through and you can map all of these relationships. And even if there's multiple relationships in one of these intersections, you can easily accommodate that as well. Sometimes you'll have 6 different relationships in one of those intersections. And that's an object matrix, people. It is a wonderful, wonderful thing. Then what you can do is you can actually prioritize after you kind of pull out those rows. You can prioritize your relationships, which is pretty cool. And then this becomes sort of the foundation for your object map. Not sort of, it is the foundation for your object map. So your object map is basically a nested object matrix that now you've added your core content and your metadata. You've added all the other attributes. And once you prioritize this, again, now you have a laundry list for all of your detail pages. Does a whole lot of other cool things too, but that is basically this lovely X-ray vision of what your system might become. And you can also see that navigation. So if I'm looking at a plant, I can see all the incidents that happened here. I can go click on one of the incidents. I can click and see the details of the incident. All right. I can click on similar incidents. I can click back to the plant that it happened on. I can click to the plant design, see other plants, right? So I can see how I might connect all the dots there. Okay, wait a second, why? Let's go back to why. We talked about why a lot. Let's revisit why. So two reasons that OUXers are just obsessed with mapping relationships. One, relationships help define the objects and context of your particular solution. The better your users or you can understand a concept, the more you can get stuff done. Like if you walk into a space, whether that is physical or digital, and you don't know what any of the things are in this space, or you have to use a lot of cognitive energy to figure out what the things are in this space, you can't really get much done. Okay. And one of the best ways, as we learned earlier with our sticky note example, one of the best ways to really understand something is to see those connections between all the other things, right? So especially if you have an object that is, I call them anchor objects. So a very clear, concrete object. It's very important to be very clear about what the other more abstract, potentially confusing, or difficult objects are in your system. You can kind of anchor them down into the more concrete object so that users can learn what those things are. Okay. So it helps define the stuff. And then reason 2, relationships will pave the way for that contextual navigation that I was sort of showing you in the object map. And I'm going to show you in actual screens in a second. So relationships pave the way for that contextual navigation, which is really the most intuitive navigation for discovery and understanding and building that understanding. Okay. So let's look at what this could actually look like. So I'm not integrating very little core content and no metadata at all. We're really just focusing on those nested objects and the relationships. So let's take a plant design, the Copenhagen design. This is actual plant design. Isn't it amazing? An actual plant was created from it. So this plant design here, if we have an image and we've got some text, maybe we even have some metadata like the date this was posted or the date that this, was proposed or something like that. Great. We can derive some meaning from this, but this becomes so much more meaningful once we start building the connections. Once we say that here's the plants that are based on this design. So right now, of course, there's only one. It's this one in Denmark. This is wishful thinking here that there would be one also in Atlanta and one in Denver. So please don't take this at face value. Concept only. So we can see the plants that were based on this design. Maybe there was just one, or maybe there was many, or maybe it might even just say this is still conceptual. There's no planned plants yet. All right. What other nested objects we want to show here? Yes, there you go, Sophia. Plant design has 0 to many plants created from it. Okay. This was our nested object matrix, right? This is just a column in our nested object matrix turned into a screen. Energy source. All right. So a plant design has one energy source. So we could see that as well. And also we had other power plants that are other power plant designs that are similar. So more power plant designs that use household waste. Maybe we can connect it through the energy source. All right. So a plant design has 0 to many similar plant designs. What do you think would happen if I click household waste right here? I go to a household waste detail page. And again, just a bunch of text, maybe some images. Okay, we can start building some meaning. We can even maybe talk about it talk about the relationships within the text. But once we pull out those relationships and we really show them in this object-oriented way, this becomes so much more meaningful and so much more useful. So we might have power plant designs that use household waste. Okay, so maybe I saw the one that I was just on, but then I see some other ones. So I can click through the other designs. And maybe even, energy source has 0 to many plant designs that use it. Maybe I even see the plant nearest you that uses household waste. And I can see that one in Atlanta that doesn't actually exist. So an energy source has one nearest plant. All right. Cool stuff, right? Now just imagine, now this is a very simple site, right? I'm just showing 2 screens, barely blocked out, very low fidelity when it comes to actually like all the metadata that would be on there. But think, if I was able to spend a little bit more time on this and we had like 10 of those objects, we brought in service providers, we brought in storage designs. Like maybe if you dug into the plant design, backing up here, if you dug into this plant design, maybe we also had, storage technologies, transmission technology, so I could learn a little bit more about that. And then when I went into the energy source detail page, maybe there was additional connections to things like policies, laws, policies, representatives that get behind a certain energy source, right? Like, which ones are my representatives? What are my local representatives that are all about, getting more wind or household waste or even nuclear, in my area, right? Maybe I want to vote for them. Maybe I don't want to vote for them. Okay. What are the ones that are, maybe this is fossil fuel. Fossil fuel would be a type. Coal is an energy source, and I can see the representatives that are really backing coal as an energy source. So adding a few more objects, adding a few more connections, this could be super, super powerful. And the cool thing about this is this is actually pretty agnostic, or it can be really agnostic. It's just presenting the information. It's just presenting the connections that are there. It's presenting the truth about the world and letting people then make their own decisions. So this doesn't even have to be biased one way or the other. It can just present, this is how the world works. This is the stuff of this domain. This is how the stuff connects. Make your own decisions, which I think is pretty cool. Okay, so I'll end with a quote from Ada Lovelace, the designer of the first algorithm. She says, all and everything is naturally related and interconnected. And I so agree with that. And then for me, I need to change my picture. It's still Ada. I'm going to do that before tomorrow. You can't change a thing before you understand a thing. To understand a thing, you have to understand its connections to other things. So if you want to be a change maker, you've got to get really good at understanding. And this is such a great tool for building understanding. So use the NOM to understand, the NOM is the nested object matrix, to understand a complex system to inform your voting, your activism, your decisions, your buying decisions, and those actions of others too. If you're going out and you are, you're maybe creating some sort of informational website, or you're helping out some organization that needs to build these connections to basically make people understand something really, really important about the environment or whatever it is that you care about. Or at the very, very least, maybe people are going to be clicking around a lot less because OOUX just helps build much more intuitive systems. So thank you very, very much. And one last thing, if you are not on the OOUX newsletter, please join the OOUX newsletter. You will get this guy. This guy is coming out on Monday. Whenever you're watching it, whenever you join, you will get the OOUX launch guide, which is a beautiful ebook. This is me just finishing it up, working on the cover with my girl Marisa. Shout out to Marisa. This is an awesome, awesome guide to get you started with OOUX. It's exactly what it sounds like. So happy OOUXing and wish me luck tomorrow.